What is the relationship between a complex number and its respective trigonometric form representation? So the first thing I want you to notice is that we have here a complex plane, and a complex plane is comprised of a real number x-axis, the horizontal axis, and the imaginary y-axis. What makes it imaginary is that even though you count the units of the y using the real numbers, you always multiply the y-coordinate by the I. So itself, the z represents the coordinates for any points plotted on the complex plane here. Z is the complex number, which is equal to x plus y times the I. So the coordinate y will always be multiplied by the I, the imaginary number I. So notice here that what we need to do here is to represent the given z complex number as x plus yi, represent this as the trigonometric form, which is equal to r times cosine of theta plus I sine of theta. Z is equal to minus 12, z is equal to minus 8i, z is equal to 2 minus 2i, etc. And we need to represent this in the trigonometric form, respective trigonometric form. Now the components that you see here, the r is called the modulus. The modulus, which represents the absolute value of the complex number z. The absolute value means that you're going to find basically the magnitude or the length of this line segment. Okay, so the z represents a point plotted on the complex plane, and the r, the length of this segment, will represent the length from the origin to that point, to whichever point that you're plotting on the complex plane. So that is called the modulus r, and that's going to be determined by taking the absolute value of the complex number z. And as you can see, the formula for that is straightforward, right? You know the components of that modulus r is the horizontal component x and the vertical component y. So basically you're squaring both of these components, you're adding them, and then you're finding the square root of that. And that gives you the modulus. Now we also call the theta the argument. The argument is going to be the angle theta that you see here, is the angle between the x component of the modulus r and the modulus r itself. Okay, so that's going to be the angle. It's very similar. The work is similar to the unit circle that you've accustomed to see before. Okay, so that's going to be the argument, and it's going to be between 0 and 2 pi, including the endpoints 0 and 2 pi. Okay, so let's start this. So how do we represent minus 12 as x in the x plus yi form? You realize that this has no I on it, right? So that means negative 12 is taken by the x coordinate, and then the y coordinate is going to be essentially 0, right? So you're going to write this as 0i. Now notice this actually represents the point minus 12, 0 in the geometric form, right? This is the geometric point in the xy plane, negative 12 comma 0. So that means it has to be on the negative x-axis. Negative x-axis corresponds to the theta angle being pi in this example. Now, if you don't understand how to find the pi using graphical means, you can also understand that theta, and I'm going to make a correction here, theta can be represented by the arctangent of y divided by x. Notice that you can find the tangent of theta is equal to y divided by the x, the opposite divided by the adjacent side. So that means the arctangent, which solves for the angle theta, is going to be arctangent of y divided by the x. Right? So we can find that out. We can find that it's actually pi instead of just looking at it by using these respective points. So as you can see, the y value is 0. So it's going to be 0 divided by minus 12. Now the arctangent of 0 is going to be pi. How do we know it's not 0? How do we know the angle is not 0? Well, it's not 0 because the given geometric point is on the negative x-axis. Okay, so we know the angle is pi and not 0, because the 0 is the positive x-axis where the countdown begins of the theta angle, right? But the theta is here. Now, don't be confused with this theta. This is just an example theta, just to show you how to find theta using the arctangent, right? This theta can be here, the right triangle. The right triangle can be in quadrant 3, quadrant 4, etc., right? This is just an example right triangle, so you see how to relate the y and x and the theta in order to find it. The modulus r here is the square root of the squares of the components x and y. The components are 12 and 0, right? So negative 12 squared is 144 plus 0, right? 0 squared. So that gives you square root of 144, which is itself 12, right? So the answer to this is, now we found those components, the modulus and the argument, so we can write it as 12 times cosine of pi plus I sine of pi. Okay, so this is the trigonometric form representation of the complex number z. Now, in the second example, to represent it in this form, the complex number z, you can write it as 0 minus 8i. Now, how do I know that this is going to work? Well, because we already have an I attached to negative 8, so we know it has to be the yi represented by negative 8i, and then the x value is 0. Okay? So the x value is 0, and y value must be negative 8, right? So this corresponds to the point in the standard coordinate plane of 0 minus 8. 0 minus 8 is going to be where? It's going to be exactly on the negative y-axis here, right? So you might think, okay, this must be 3 pi over 2 for the theta angle. Let's confirm that algebraically. Before we do that, let's actually find the modulus. The modulus r. So the modulus r is going to be the square root of the components. Okay? So this represents a point. 0 minus 8i represents a point in the complex plane. And in the standard coordinate plane, in the real number system, this corresponds to the point 0 minus 8 graphically. So this is going to be what? 0 squared plus negative 8 squared, which is 64. So that gives us square root of 64, which is 8. Okay? So r is equal to 8, so we can go ahead and write 8 here. Now the theta angle, we already speculated that it's going to be 3 pi over 2 because of the position of the coordinate 0, comma negative 8, geometric position. But let's confirm that. So theta is equal to arctangent of y divided by the x, right? So the arctangent of y divided by the x. So negative 8 divided by 0. Now, can we actually find that? So realize that negative 8 divided by 0 is undefined. So how do we know what the tangent is if it's undefined? Well, it's undefined in two ways. Only when there's a pi over 2 angle, or when there is a 3 pi over 2 angle. In this case, since the point is on the negative y-axis here, we know that it's going to be definitely 3 pi over 2. Okay? So angle is going to be 3 pi over 2. Because negative 8 divided by 0 is basically giving you a negative infinity, right? It's not even a number, right? It's negatively infinite. You can't even count that. So we know the arctangent of that must be 3 pi over 2. Okay, so now that we found it, we can go ahead and write this in trigonometric form. Cosine of 3 pi divided by 2 plus I sine of 3 pi over 2. So that would be the answer. That would be the trigonometric form. Now, the next question, Easier in the sense that it has both components that you've used to see in the x plus yi, the complex number z. So we can write it as, first of all, let's find the corresponding point. So 2 minus 2i, right? So you go 2 to the right and 2i down, right, for the negative y-axis. So you're going to be in quadrant 4. The angle that you're going to have is going to be in quadrant 4 for sure. So the geometric point corresponding to this is going to be 2 minus 2. Okay? The modulus r is going to be the square root of the components. Components x and y. Don't square the I by accident, right? Just square the 2. All right? So square the negative 2, right? So that's going to be 2 squared plus minus 2 squared, right? Squaring the x and y. So that gives us what? That gives us 4 plus 4, which is radical 8. 4 plus 4, radical 8, or we can write it as 4 times 2, or 2 radical 2. Okay, so that's the r value. Now the theta value, we already said that the angle must be in quadrant 4 because of the point here. But let's see. So the arctangent of negative 2 over 2. Negative 2 over 2 is the same thing as negative 1. We know the arctangent of negative 1 can be two different angles, right? It can be 3 pi over 4, or it can be 7 pi over 4. 3 pi over 4 is in quadrant 2, 7 pi over 4 is in quadrant 4. Thus, the angle measure must be 7 pi over 4 in radians, because this corresponds to quadrant 4. So we can write this as 2 radical 2 being the modulus r here, and then cosine of 7 pi over 4 plus I sine of 7 pi over 4. So if you check this back, you should get the original point, the original complex number. Okay, now finally we have this. This corresponds to geometric point minus radical 3 comma 1. Okay? Because again, the way to find that, the way to see it is to compare with the x plus yi representation of the complex number z. As you can see, x is by itself, which is negative radical 3. The y is the coefficient of the I, which in this case is 1. Okay? So we have the respective points x and y, negative radical 3 comma 1. So now the modulus r is going to be the sum of the squares square rooted, right? So minus radical 3 squared plus 1 squared. So that gives us 3 plus 1, which is radical 4, which is 2. So we can write it as 2 and then times. Now we need to find the argument theta. So the argument theta, now just judging by this point here, negative radical 3, 1, right? So, or we can think of it as negative radical 3 plus I, negative radical 3 plus I. So we have to be in quadrant 2 of the complex plane. Now this geometric point also corresponds to the same quadrant, as it should, right? Quadrant 2. So we know the theta angle isn't definitely in quadrant 2, not on the positive y-axis or the negative x-axis, but in between them, right? In quadrant 2 here. So it's going to be what? It's going to be arctangent of the quotient of the y component and the x component of the modulus r, right? So y divided by the x, and that's going to be 1 over, rather negative over radical 3, right? Because of the negative sign. And notice that this, you can also say, this means angle whose tangent is negative 1 over radical 3, right? So you can represent this also as minus 1/2, or I would say just positive 1/2, divided by the negative radical 3 over 2, right? Notice that you can write it that way. And then you can easily see, because tangent is going to be the top divided by the bottom, and that's going to be the sine divided by the cosine. Recall that, right? Which is the same thing as saying angle whose sine is 1/2 and the cosine is negative radical 3 over 2. Right? So the sine is positive, the cosine is negative. Sine is positive, cosine negative can only be in quadrant 2, as we suspected earlier, right? Because the sine accounts for the y value, the vertical motion. The cosine represents for the horizontal motion, okay? Or left or right motion. So in this case, the x value is negative and the y value is positive, right? 1/2. So this must be in quadrant 2. Now, which angle measure corresponds to that? Which angle makes sure that sine of that angle is 1/2 and the cosine of that angle is negative radical 3 over 2? It must be 5 pi over 6. There's no other way. Sine of 5 pi over 6 is 1/2. Cosine of 5 pi over 6 is negative radical 3 over 2. Thus, the tangent of 5 pi over 6 is exactly negative 1 over root 3. Okay, because the 2's would cancel out, right? 2's cancel out. The result is negative 1 over radical 3. Okay, so 5 pi over 6. So now this means that we have the result cosine of 5 pi over 6 plus I sine of 5 pi over 6. Okay, so I hope this was useful and fun. Thanks so much for watching and see you in the next video.